I'm Sarah Hamylton and I work at the University of Wollongong as a GIS lecturer in the School of Earth and Environmental Sciences. And I do research on coastlines, looking at mapping coastal systems and using those digital maps as a basis for modelling things like the effects of climate change on coasts. The objectives of the Joint Benthic Field and Remote Sensing Survey were essentially to use satellite imagery to map a series of about 21 islands in the southern Great Barrier Reef called the Capricorn Bunker Group. The reason that we were doing that mapping was we were trying to generate a series of digital data sets that were going to provide a source of quite important information for things like assessing change over the last 12 years and also trying to quantify this important process of calcification that goes on around the reefs. So when you're looking at the Great Barrier Reef structure, that entire structure itself really is built up from calcium carbonate. Essentially, what we were trying to do was do some ground truthing surveys which would support making detailed maps of the reef systems from the satellite images that we had. And at the most basic level, what you need is a geo-referenced record of what's on the sea floor. When I say geo-referenced, I mean you've got to have coordinates associated with it so you can plot it on the image. So we were doing from a boat by lowering down an underwater camera, and using the boat approach gave us a few advantages insofar as we were able to cover a much broader area across the entire reef system. Some of these reef systems were about 12 kilometres long. We also had the camera on a length of 50 metres worth of cable, so we were able to go out into much deeper areas and lower it down and see what was on the seafloor there. And using the satellite imagery, you can generally map down, if you've got clear water, to a depth of about 25 metres. So the digital maps are pretty important data sets in their own right insofar as they're georeference, which means that we can plot any other form of information on top of them. So one thing that we're hoping to do with them is we've got a series of surveys that were taken back in 2001, and that's essentially a detailed census of what's on the seafloor in terms of the different communities there, the corals, the sponges, the algae, etc. And so we've revisited those places, and we're hoping to undertake the same census and then compare our more recent data set to those older data sets. There are a whole suite of changes that could influence calcification as a process. So there are things like ocean acidification, coral bleaching, the increased frequency and intensity of storms and cyclones, and then superimposed on top of that there are more local effects, things like the input of nutrients from the Queensland catchment that washing down into the sea, and how that has follow-on effects for things like crown of thorns and those populations coming in onto the reef and just causing destruction. And so remote sensing, the kind of satellite imagery work that I do, is necessarily an observational science. So you've got to go out there, take nature as it comes, and try to link that through to what can sometimes seem to be a disparate process, such as the various aspects of climate change. So definitely out there on the reef there is a lot of dead coral, and we're working hard to link that through to aspects of climate change and do so at a scale that's functionally meaningful. So rather than just going out and taking a dive and looking at a particular localised area, we're using the approach with the satellite imagery to try and answer these questions for whole reef islands and reef scales.